as a rough sketch, this is fine. We're going to fine tune it a little bit though, because as you can see, we've got intercepts there. And it would be really nice to know anytime you're doing a sketch of a graph what the relevant points are. So we want to change those lines just a little bit, hone in on exactly where they cross. We're going to have to do that by finding those intercepts. So if I have a y-intercept, that's where x equals 0. So that's easy to find out. You just plug in x, or plug in 0 for x. If I were, whoops, guess I should have redrawn the entire equation, sorry about that. So if I want to find out what my y-intercept is, I just plug x into the equation. So 2 times 0 squared plus 5 times 0 minus 12 all over 0 plus 2. Well, you can see that all of this is just 0. So what we're left with is negative 12 over 2. So it's going to end up being negative 6. That means that we've got y-intercept at 0 and negative 6. So if I look at this line where 0 is, this should have actually been down a little further if I were to draw it a little more accurately. And through there. Then up. All right? I know your graphs are going to be tidier than mine. I've still got a couple of points on there, these ones, which are my x-intercepts. So at the x-intercepts, y is 0. Unfortunately, the best way to find this out is to actually factor that original equation. So when we come into contact with something like this, we can't really avoid that factoring situation. So we're just going to look at the top part of that graph, and we're going to make it y equals 2x squared plus 5x minus 12. And then we could do decomp, because I hate guess and check. So I go 2 times negative 12 equals negative 24. What are the factors of negative 24? 1 and 24, 2 and 12, 3 and 8, 4 and 6. Which one has a difference of 5? Well, it's 3 and 8 must be the positive one, so that makes that one negative. So I'm going to do my little decomp thing and put those middle terms in there where they should be. And then I'm going to take the factors that are common out of the first two, so there's really only x, so it becomes 2x minus 3. And then I take the factors out of the last two that are common, it looks like just plus 4, and that leaves me with 2x minus 3. I know the brackets match, so I have x plus 4 and 2x minus 3. So if I look at this one and I want to find out what makes this 0, for this one it would be x is negative, x is negative 4, and this one is going to be x is 3 over 2. That means those are my points over there. So this one actually looks like it's pretty good. I'm not going to redraw it. That's 3 over 2. And this one I'm going to label as negative 4. Put a dot in there. Yay! There it is. Okay, so now you've got your intercepts written on there. Should have written this negative 6 in. And your graph is a lot more accurate than just throwing those lines in wherever. The other thing that I needed to talk to you about was domain and range. The easiest thing to do when you're figuring out domain and range is to look at your graph and ask yourself, what are the restrictions on my x for my domain and my y for my range? So the domain in this case, if I'm looking this way across the graph, there's only one value for x that doesn't work. So it's just this 2. The domain is x cannot equal negative 2. If I look at range, now I'm looking at the y values. Well, if I look this way on my graph, there's points everywhere. So that means that I don't actually have a limitation on what y can be. So y is in the realm of all real numbers. So when you're doing your domain and range, the best thing to do is just have a look at your graph once you've finished making it and choose your domain and range given that data.